So, this is the integration that I came across yesterday, but yeah, I solved it like using some algebraic patterns and some algebraic skills, and basically the integration skills. So, let's have a look how I did it. So, first of all, I'll be showing you the graph of it just to understand what type of integration is it and which area we are going to find out. So, yeah, let's have a look at the graphs. So this is a graph of 1 by x to the power 4 plus 1 that you have to be pretty much familiar of so that it be more like type of a realistic one when you are solving these kinds of problems. So let's go through the integration part. So for integration you have to know some formulas that is presented in the left hand side, and the formulas like dx by x squared plus a squared that is equal to 1 by a tan inverse x by a, and another formula is dx by x squared minus a squared that will be equal to 1 by 2a log x minus a by x plus a. So these are the formulas that we'll be needing, which is a kind of a standard formula, but yeah, I've used these formulas to solve this question, so to not to confuse you from where this formulas came. So it came from this stuff. So in another video I will be going to prove these problems and prove these formulas, and let's go through the main idea of this integration. So you have to like basically form a plan. So my plan was to get two terms, so I got the two terms which is written in the below line. So it's 1 by 2 integral of 0 to 1 x squared plus 1 by x to the power 4 plus 1 minus x to the power squared minus 1 by x to the power 4 plus 1. You can have a look that x squared cancels each other after the LCM is taken, and 2 is also cancelled. So this is a valid conclusion that it can be written in this way. So let's see what we have to do next. So now try to make both numerator and denominator in terms of x squared. So how you'll do it? Come on, think of it. So you have to bring x squared in both numerator and denominator in the equation shown below. So let me give you a clue. So the clue is divide numerator and denominator by x squared. So if you did it, you'll magically be occurring with this form. So this form just represents it in x squared, because every denominator and numerators are in x squared terms, so it'll be more easier to form integration in this kinds of situation. So now what I'm going to do is I'm just going to divide the integration sign into both sides. So I'll say that 1 by 2 integral of 0 to 1 1 plus 1 by x squared upon x squared plus 1 by x squared dx minus integral of 0 to 1 1 minus 1 by x squared upon x squared plus 1 by x squared dx. This is how you are going to separate these two terms. Like now what you need to do is you have to integrate the first one. So the first one, integrate the first one. So the first one is 1 plus 1 by x squared by x squared plus 1 by x squared. So that can be written as the integral. So now use the u substitution, and for integral use the u substitution method. So now before you do u substitution, you have to always keep in mind that you have to always look at the numerator term, because in u substitution it is common to cancel out numerator terms and you'll get a definite term that will be integrated. That will be really easy. So after taking the derivative of the u, so as I have taken right now the variable u of u as x minus 1 by x, so take its derivative, you'll get this term 1 plus 1 by x squared. So now what is dx then? dx will be written as du by 1 plus 1 by x squared. Now substitute that value in the original integral and you'll get the right hand side term. So integral of 0 to 1 du by x squared plus 1 by x squared. Now you have to use the basis of algebraic formulas. So the algebraic formulas that you have learned in schools is a squared plus b squared. The formula of a squared plus b squared, it's a plus b whole squared minus 2ab or a minus b whole squared plus 2ab. That's the formula that I've used in the next step. So I've used x squared plus 1 by x squared in terms of a squared plus b squared, that is equal to x minus 1 by x whole squared plus 2. So now this is getting really easier because you can now generate some ideas about comparing it with the formulas. So if you compare the equation, the denominator, by the formula that I've shown you previously, it comes to be this term right here. So at the end, so you'll get this term. So it's easier to see this, but it's difficult to recognize the patterns, right? And one more thing, you have to substitute the values of x, meaning you have to substitute the lower limits and the upper limits of x to get the lower limit and upper limit of u that I've done in line number 3. So according to the formulas and using some basic ideas about the integration and formulating and comparing it with the formula that I've shown you before, you'll get this term. So you have to use the same idea in the next integral as well. So the next integral is this 1 minus 1 by x squared. So for that integral, as the base is same, as the denominator is same, you have to now formulate the same idea. So the idea comes that I need after derivative of some after derivative of some function, I need to get the same term as numerator. So how do I get it? It's simple. Just you substitute it by x plus 1 by x. So taking its derivative, you will get the same term so that the numerator cancels out and you will get a completely, and you can completely handle the case. You have to change the limits of u with respect to x. So keep the lower limits and upper limits of x and find the values of u. And after you do it, you'll get this integral that is shown in the bottom half of the line. So let's see. Now what you have to do is you have to just combine everything and you will get a final equation. But I haven't reached to till the final value, but I've reached to the final integration part. So yeah, from there it'll be more easy to solve for the value of 1 by x to the power 4 plus 1. What is its complete area? But I haven't done that. I've just like found the equation for that. So the equation that represents the whole part of this integration is this. So if you have any questions, you can comment below. Thank you.